Okay, now let's move on to the last discussion topic of this week. Well, it's actually two, but one, economic versus accounting cost, and then cost minimizing input choices. That's what we do for the remaining of this week. Let's go. Before we talk about cost minimization, it is important to make clear which cost we're talking about. Yeah? So for that reason important to differentiate between accounting cost and economic cost. The accountant's cost due with the out-of-pocket or historical expenses. So one of the most important principle in accounting is you only record one expenditure as cost when it's occurred, not as foreseeable or some opportunity cost, like cost that could have incurred. No, it must actually happen already. Contradicting to that, economists interested more on opportunity cost. Now, for example, what is opportunity cost? So you receive a ticket for a concert worth 30 euro as birthday gift or Christmas gift, for example. And the concert lasts 2 hours. Okay. Last minute, you have to stay home to do microeconomics assignment because it's too hard. And you spend the entire 2 hours on your assignment instead of going to the concert. So the opportunity cost in this case of solving the assignment is 30 euro, the price of the ticket, plus all the happiness associated with that concert. Okay. Another example. Now you decided to go for the same concert instead of doing some consultant job that somebody offered to you, which worth or would earn you 75 euro per hour. So the opportunity cost of this concert is now 75 times 2 because 2 hours, right? 150 euro. So these are some examples. Yeah, I'm teasing you a bit, but just for you to imagine. Okay, that is opportunity cost. So back to the production context. The economic cost of any input is the payment required to keep that input in its present employment. How does it mean? So that means the opportunity cost of the input is the best, or the payment that would earn you in its best alternative employment. Another example, I grow maize on my field now, and I have two harvesters to harvest the maize. My neighbor grows rapeseed now, and he has only one harvester. Okay, and just suddenly this year, rapeseed, the price of rapeseed is so good, and his harvest is also so good that for that moment he cannot miss that because of the weather, and so he wanted to harvest as quickly as possible. So he came to me and asked if he could rent one of my harvester. So now with all the cost, that the historical cost that I spent to invest into this harvester, I calculated that, okay, the cost for one machine hour for this harvester is 100 euro per hour now. But then the neighbor willing to offer me 150 euro per hour. So there I have two options. Either I will keep the harvester to use for my own harvesting of maize, right? And that would cost me 150 euro, not 100. Keep that in mind. There's a opportunity cost. So it's like the best alternative employment. That was 150 what the neighbor offered me. That's the opportunity cost of the first option. Second option, I rent it to him for 150 euro per hour. And somehow I managed to increase the labor input to my harvest, which is at the moment somehow less expensive. So I change the input mix of my production in a way. Now, so that is one way to think about costs in the production context and why sometimes we need to change the input mix in order to minimize the cost, including the opportunity cost. Okay, let's put out some general frameworks for the analysis later with the definition of cost, revenue, and profit. Yeah, a bit off track when we talk about profit at this stage, and we're jumping ahead a bit, but I tell you why later. So total cost for the firm are given by assuming the firm only used to input labor and capital, the total cost denoted as C, equals the cost of labor, which is the price of labor input wage, for example, W, times the total labor quantity used, right? And the same thing goes for capital. Price of capital times the quantity of capital. So that's the total cost. The second thing is revenue. Revenue is what the firm earns by selling its product, right? So the total revenue will be the price of the output P times the quantity Q. So where the quantity is expressed or summarized by your production function. We talk about it now. So here P equivalent to P times FKL, a function of input, here capital and labor. In these two definitions, there's some implicit assumption there. The first thing about a cost is the price of input assumed exogenous or given to the firm. So it has no influence on the market price of input, capital, and labor by its quantity of usage of labor and capital. So the amount of it is usually not large enough to influence the market. Similarly, for the revenue, the market price of its output is also assumed to be given to the firm. So it also has no significant influence to the market price through its market share. It's like competitive market. That's the two assumptions. With this in mind, now we really go up track to the economic profits. Denoted usually is pi equals to the difference between the revenue and the cost, right? Revenue minus cost. Very straightforward. And you plug in what is given in the above definitions. And you have at the end, the profit is P times F minus WL minus VK. Now, very intuitive. And why we interested in profit at all? I assume that in the introductory microeconomic course, they must have taught you already that the ultimate goal of the firm is making profits. So that's like one of the most important assumption in production economics. That's the ultimate goal of firm is maximizing its profit. Even though here and there will also be other objective or goals, but that's the most basic thing we stick to here, right? And for that, written that way, we could see that economic profits as the function of the amount or the quantity of K and L, which are employed employed in the production. And if we want to maximize the profit, we could think about a maximization problem here where we choose the quantity of K and L to maximize the profit directly in the profit. If that's the case, like if profit is the ultimate goal, why don't we do that directly, skipping the cost minimization? Why do we have to do that? The thing is, with cost minimization, we first don't look at the second assumption about the market or the exogenous market price of the output, which holds only for competitive market. No? And because of that, cost minimization has its a wider range of applications for other firms not in competitive market. So first we look at it. And the second reason is, as we go into the profit maximization later of this part next week, maybe you will see that you will, on the way coming to profit maximization, you will arrive at similar result, similar intuition or insight that you obtain from here. So starting from cost minimization is somehow make it easier for you later to grasp the concept of profit maximization. Because of that, for now, we will assume that the firm has already chosen its output level, Q0, yeah? And try to minimize the cost of producing this level of output. Let's first look at the graphical illustration of the cost minimization problem here, and then you will see that it's very, very similar to the expenditure minimization problem that we have gone through in the demand and choice part. So here we have again an isoquant with a fixed level, a given level of output Q0, and our objective is to find the least costly point on the isoquant. It's similar to the utility or the indifferent curve before, right? So we wanted to find the combination of input mixed or like input uses, which will give us the most cost saving possibility to produce the level of output Q0. Now, how would the cost line look like on this graph? So it's represented by parallel lines with a slope of minus W over V. Why? Remember, the cost is C equal to WL plus VK, right? And remember the thing with the budget constraint, to draw a line, we need to arrive in a line equation. So like here, the cost line equation, which we solve for K as a function of L and T, right? So for that, we have C minus WL equals VK, right? And now we divide both sides for V. So we have K equal C over V minus W over V times L, right? So here we got the intercept is C over V. And then the slope. What is the slope? The slope is the derivative of K with respect to L, which is minus W over V, right? So this is slope. And that is why it's very similar to the budget line case before. Now, so because of this, like, it's a linear equation, right? So the slope remains unchanged when you move upper to a higher level of cost. So the further you move from the origin or the right, the more you shift toward the right hand side, cost will increase. Huh? I will clean this so you see the slide. Okay, so that was the idea. Now we find a minimum cost, like the cost line that will give us the minimum cost, or like the most cost saving possibility to produce Q0. Okay, and why is that C2? You still remember from the expenditure minimization? Because it's like the only line that tangent the isoquant. Now, at C1, you have smaller cost, cheaper. However, because it's to the left of the isoquant, you will produce something less than the targeted output level Q0. On the other hand, if you use C3, what happens? C3 is to the right hand side of C1 and C2. That means it's more expensive to produce at that level, and you actually can produce more, not Q0 at that C3. So if you want to produce Q0 at C3, that's definitely more expensive and unnecessary, right? So the only possibility here that gives you the minimized cost is C2. That's the idea. And at that tangent point between the cost line and the isoquant, the optimal choice given is the level of labor, L star, and the level of capital, K star. So again, this is a constraint optimization or constraint minimization problem. So we could again apply the Lagrange approach to solve for the optimum level of L and K. Why constraint? Because we have a targeted level of output that we wanted to produce. Like before, we have a targeted level of utility that we wanted to achieve, like, right? So we could actually write it as of C equal L times W plus K times V with subject to the constraint Q equal F K L equal Q0, right? And we search for K and L level. So that's our constraint minimization problem over here. The approach very standard, nothing very different or nothing even different from before. We set up the Lagrange function, which including our objective function over here, plus the lambda times the constraint. The lambda is the Lagrange multiplier, right? And then we derive the first order condition. For now, let's just ignore the second order condition. So the first order condition required that you set the first partial derivative of the Lagrange with respect to each variable L, K, and lambda must be 0. So you set them to 0. That's the first order condition. So if you take the first derivative of L with respect to of the Lagrange, let's not get confused with that now. Of the Lagrange with respect to labor L, so it's equal W, because here WL now VK has no L, so it's gone, minus lambda and the derivative of the production function with respect to labor. Similar for the case of capital, right? And let's call it the first, the second, and the third equation over here. So the third equation with respect to the lambda with turn to the constraint must be equal to 0. That's what we have done. So dividing the first two conditions after rearrangement. So let's go back again to see what's the first two conditions, which is the partial derivative of the Lagrange with respect to the two inputs, right? So we would have something like W over V equals the first derivative of the production function with respect to L over the first derivative of the production function with respect to K. And what are they? So that is the marginal productivity of L over the marginal productivity of K. And we have shown last week, it's by definition the marginal rate of substitution, marginal rate of technical substitution of L for K. Now, what is the implication of this? So the cost minimizing solution occurred when the RTS, the marginal rate of technical substitution of the two inputs for the technical or for the production function that the firm adopts, it must equal the ratio of their prices, the market prices that they traded on the market. We could also cross multiply this part, cross multiply to get the ratio MPK over V equal MPL over W. How do we understand that? So the implication is for cost to be minimized. the marginal productivity per dollar, because here's the price, right? The price you spend for an extra unit of capital, and here's the price you spend for an extra unit of labor. So at the end, the marginal productivity per dollar that you spend on this extra unit of input should be the same for all input. Why? Because if, for example, the marginal productivity per dollar you spend on K is, let's say, larger than that of labor, then you would want to use more K instead of L, right? So it's not yet the optimum point to choose. And the same also holds if the other possibility occur, where you have the marginal productivity of labor per dollar is larger than that of capital. So you could still adjust, and that's not yet the optimum input mix. After we solve for the first order condition for the two inputs, we will get the input demand function, just as we got the goods demand function before from the expenditure minimization problem. So the function of K and L at the optimum point now is the function of the prices of the two inputs and the fixed level of output that you targeted. Nah? And before that, remember, they call contingent input demand. Contingent means conditional. Why? Because they depend on the fixed output Q0. They're not free, so they constrained already. So that's called contingent input demand function. And like I said many times until now, it's very similar to the Hicks or the compensated demand function for consumption, like we had before. Remember, before that we have something like X P1 or PX PY U0, right? The targeted utility level and or the targeted utility or the targeted happiness level, and the happiness of the firm is production level. So they analog to each other. After having solved for L star and K star, the contingent input demand, we can plug it back to the definition of the total cost again. And what we have at the end is a function of prices of the input and Q. And that is called the cost function, which is the counterpart of the expenditure function before. And with this cost function, we can calculate the minimum cost incurred by the firm for any set of input prices and for any output level. And because it's for any output level, you could adjust the output level. That's why here the subscript 0 is gone. So for now, you could see the minimum cost for different level of output. Now,